Hi friends, in this video let us discuss about solution of homogeneous PDE involving one independent variable only. So how to solve homogeneous PDE? So in case of homogeneous PDE, here we apply the method of solving homogeneous linear differential equations to solve the homogeneous partial differential equation. So we are already familiar with how to solve homogeneous linear differential equations of higher order. The same technique we apply here. Let us recapitulate. So solution of homogeneous linear differential equation. So if consider the linear differential equation a d square y by dx square plus b dy by dx plus cy equal to 0. If this is the homogeneous linear differential equation, so put d by dx capital D, we put d by dx capital D. So when you substitute here, a d square by dx square is capital D square into y plus b dy plus cy equal to 0. So here throughout y is common, so if you take common, a d square plus b d plus c equal into y equal to 0. So here whatever the d term is there, here replace d by m. So we get a m square plus bm plus c equal to 0, which we call it as auxiliary equation or intermediate equation. Based on nature of roots of auxiliary equation, we write solution. So it is a general equation, let the roots be m1 and m2. So then if any two values if you consider for a quadratic equation as roots, then three cases arises. So one is they are not equal, real and not equal, or equal case and complex case. So if they are not equal, roots are real and not equal, we write solution as y equal to c1 e raised to m1x plus c2 e raised to m2x. So if both are equal, m1 m2 equal to m means 2 2 3 3, like that roots if we get, we write solution as y equal to c1 plus c2x into e raised to mx. Next, if complex, so we know that complex roots exist in conjugate pairs. So if one is 1 plus alpha plus I beta, another will be alpha minus I beta. If this is the case, we write solution as y equal to e raised to alpha x into bracket c1 cos beta x plus c2 sin beta x. So like this we solve homogeneous linear differential equation. So in the same way we go for solving homogeneous partial differential equations. So let us solve this example which was given in VTU June 2019 examination. So the question is, solve dou square z by dou x square plus z equal to 0 such that z equal to e raised to y when x 0 and dou z by dou x equal to 1 when x 0. So these are the conditions which have been given. So before going for condition, so whenever a question is given like solve, then identify homogeneous or non-homogeneous. So now we know that z is function of xy. Z is function of xy means z is dependent variable. So only z and here dependent variable and its derivative it is having. So this is called homogeneous partial differential equation. So in case of homogeneous, we apply the method of solving linear differential equation. So let us solve it. So whatever the dou square z by dou x square plus z equal to 0, consider this equation. So now here derivative is dou by dou x. So put dou by dou x equal to capital D. So if you substitute dou by dou x capital D, what we get? Here dou square by dou x square, so capital D square z plus z equal to 0. So if z common, if you take d square plus 1 into z equal to 0. So now d square plus 1 is the derivative term, so where we need to consider that part. From that we write auxiliary equation by replacing d by m. So it can be written as m square plus 1 equal to 0. So now here we need to find the roots of auxiliary equation. So m square equal to minus 1 m equal to plus or minus square root of minus 1, so plus or minus I. So we got the roots alpha plus I beta form, so 0 plus or minus 1I, in that form we got, where this is 0 is alpha and 1 is beta. So from this we can write solution. So here observe derivative, so that is dou z by dou x, dou square z by dou x square means z in terms of x we need to write. So z equal to c1 e raised to 0x into c1 cos 1x plus c2 sin 1x. So e raised to 0 is 1, so c1 cos x plus c2 sin x. So like this, if dou z by dou x is there, we need to write z in terms of x. But we know in case of partial differentiation, so that is when you are differentiating with respect to x, we treat y term as constant. So here constants are c1 is y term, f of y cos x plus c2 some g of y sin x, z equal to this. So this is the general integral, general solution, we call general solution of given problem. But along with this, in this problem it has been given the conditions. So here given z equal to e raised to y when x equal to 0. So substitute this in 1. So z is e raised to y when x 0, cos 0 is 1. So f of y plus g of y sin 0. So we know sin 0 is 0. So it is 0. So we got f of y equal to e raised to y. So this is one term we got. Now let us apply second condition, dou z by dou x 1 when x 0. So for which we require dou z by dou x. So whatever the one is there which is z, differentiate with respect to x partially. So differentiate 1 partially with respect to x. So differentiate. So we get dou z by dou x. Dou z by dou x equal to f of y cos x, partial differentiation, cos x differentiation minus sin x plus g of y sin x differentiation cos x. So this is what we got. Now apply the condition. So here it has been given dou z by dou x equal to 1 when x 0. Substitute this, dou z by dou x 1 when x 0. So substitute x 0 sin 0 0. So plus g of y cos 0 1. So g of y into 1. So we got g of y equal to 1. So now we got both arbitrary terms f of y as well as g of y. So same thing, whatever you got, substitute in equation 1. So z equal to from 1 z equal to f of y, that is e raised to y cos x plus g of y, that is 1 sin x. So this is the final required solution of given problem. Now let us solve another problem which has been given in VTU 2016 exams. So solve dou square z by dou y square equal to z, given that when y 0, z equal to e raised to x and dou z by dou x is e raised to minus x. So now consider the given equation, dou square z by dou y square equal to z. So forget about this part, we will apply later on. So now z take this side. So dou square z by dou y square minus z equal to 0. So here derivative is dou by dou y. So put dou by dou y equal to capital D. So substitute capital D. So if you substitute capital D, we get d square z minus z equal to 0. Or if z common, if you take d square minus 1 into z equal to 0. So here we can write auxiliary equation as by replacing d by m. So m square minus 1 equal to 0. So then m square equal to 1, m equal to plus or minus 1, or we get roots as 1 and minus 1. So we got two roots, 1 minus 1. So now these are not equal, both are not equal, so we write z as, so here derivative is dou z by dou I, means z in terms of y you need to write. So z equal to c1 e raised to, not equal means e raised to m1x c1x 1y plus c2 e raised to minus 1y. So this is what we have written. But another thing is, when we are differentiating partially with respect to y, we treat x term as constant. So it means constants are x terms. So here constants c1 can be written as f of x e raised to y plus g of x e raised to minus y. So z equal to this we got. So take this as equation number 1. So now once you get this, then you go for applying the conditions. So now, so it has been given that if when y is 0, z equal to e raised to x. So given z equal to e raised to x when y equal to 0. So let us apply this condition. So now z equal to e raised to x when y 0. So f of x into e raised to 0, y e raised to y, e raised to 0 is 1 plus g of x e raised to 0 1. So f of x plus g of x equal to e raised to x. So take this as some equation number 2. Now let us apply another condition when y 0 dou z by dou y equal to this. So it means we need to apply this condition, you need dou z by dou y. So for that what we can do is differentiate 1 z with respect to y. So differentiate 1 partially with respect to y. So we get dou z by dou y. Dou z by dou y equal to f of x e raised to y. So f of x e raised to y differentiation e raised to y plus g of x e raised to minus y differentiation minus e raised to minus y. So now apply the condition. So given when y 0 dou z by dou y equal to e raised to minus x. So apply this one. Dou z by dou y is e raised to minus x, e raised to minus x. So when y is 0, so put y 0, f of x e raised to 0 plus g of x minus sign g of x e raised to 0. So means 1. So now we got this. Take this as equation number 3. By using equation 2 and equation 3, we need to get expression for f of x and g of x. So when you add 2 plus 3, so 2 plus 3, so add both, so that is f of x plus g of x equal to e raised to x. So then f of x minus g of x equal to e raised to minus x. So when you add both, so g of x get cancels. 2 times f of x equal to e raised to x plus e raised to minus x. So now f of x equal to, so that is e raised to x plus e raised to minus x by 2 we get. So consider this one as f of x. So next thing is we need g of x. So for that you can consider any equation. So first equation, f of x plus from 2 we get, from 2 what we get is g of x equal to e raised to x minus f of x, e raised to x minus f of x. So e raised to x minus f of x is e raised to x plus e raised to minus x by 2. So when you simplify, so what we get is, so 2 times e raised to x minus e raised to x, that is e raised to x minus e raised to minus x divided by 2. So that we get g of x. So now, so when you simplify this one, so we know e raised to x minus e raised to minus x by 2 is sine hyperbolic x. In the same way, f of x is e raised to x plus e raised to minus x by 2, that is cos hyperbolic x. So f of x is cos hyperbolic x and g of x is sine hyperbolic x. So once you get both, you substitute in equation number 1. So from 1, so what we get is z equal to cos hyperbolic x into e raised to y plus sine hyperbolic x e raised to minus y. So this is the required solution. Let us solve another problem. Solve dou square z by dou x square equal to a square z when x 0, dou z by dou x equal to a sin y and z is 0. So this is the given problem which has been given in VTU exams, then in 2019. So now consider the given equation as it is. So that is dou square z by dou x square equal to a square z as it is. So now it is having only z and its derivatives of z, that's why we call it as homogeneous PDE. So if homogeneous, we apply the method of solving linear differential equations to solve the same. So now here take this side, so dou square z by dou x square minus a square z equal to 0. So here dou by dou x is the derivative, so put derivative dou by dou x equal to capital D. So when you substitute this dou by dou x, so here you will get d square z minus a square z equal to 0 or d square minus a square into z equal to 0. So now, so from this you can write easily auxiliary equation, that is by replacing d by m. So m square minus a square equal to 0, m square equal to a square, m equal to plus or minus a, or m values are a and minus a. So this is how we got the roots. So those roots are a and minus a. So a minus a not equal roots, distinct, real and distinct. So that case you need to apply. So here, so look at the derivative dou z by dou x. So it means z you need to write in terms of x. So now, so solution z equal to c1 e raised to ax plus c2 e raised to minus ax. So like this you need to write. So but here c1 and c2 are constants. So whenever it is a partial differentiation, when we are differentiating with respect to x, y term is constant. So it means, so here whatever the constants we have considered, these are y terms. So that we write it as, so f of y e raised to ax plus g of y e raised to minus x. So consider this as equation number 1. So now, so once you get this, then you go for applying the given conditions. So there it has been given that when x 0, z 0. So given when x 0, z is 0, apply this condition. So z 0, x 0, when x 0. So f of y e raised to 0, 1. So g of y e raised to 0, 1. So f of y plus g of y equal to 0 we got. So take this as equation number 2. So now let us apply second condition. When x 0, dou z by dou y, dou z by dou x is a sin y. So to apply this condition, so what you can do is get dou z by dou x. So differentiate 1 with respect to x partially. So differentiate 1 partially with respect to x. So differentiate. So then we get dou z by dou x. So that is dou z by dou x is f of y into e raised to x derivative a into e raised to ax plus g of y e raised to minus ax differentiation minus a e raised to minus ax. So now apply the condition. Dou z by given dou z by dou x is a sin y when x equal to 0, so apply a sin y, dou z by a sin y when x 0, so put x 0, so a into f of y into e raised to 0 is 1, so minus a g of y e raised to 0, that is also 1. So we got, so throughout here if you look, throughout it is a common, so that will get cancelled. So take this as equation number 3. So now then using 1, 2 and 3 you need to get the expression for f of I and g of I. So f of I plus g of I, f of I minus g of I is there. So when you add, this get cancels and you are going to get f of I. So add 2 plus 3, add this one. So equation 2 is f of y plus g of I equal to 0. Here f of y minus g of y equal to sin y. So when you add g of y minus g of y get cancels, 2 times f of y equal to sin y we get, or f of y is sin y divided by 2, sin y by 2. So this is what we get. Now once you get this, then you substitute in 2. So from equation 2, so what we get is g of y is minus f of y. So minus of f of y is minus sin y by 2. So that is g of y. So once you get f of y, g of y, so you substitute in 1. So from 1, z equal to, so f of y sin y by 2 e raised to ax, g of y that is minus sin y by 2 into e raised to minus ax. So here sin y common, sin y by 2 common. If you take sin y divided by 2, if it is as common, so then it can be written as e raised to ax minus e raised to minus ax. So here sin y as it is, so now e raised to ax minus e raised to minus ax by 2, so this itself is sin hyperbolic ax. So z equal to this we got. This is the required solution.